Okay, this is our second weekly question and answer session. Several of you posted questions that had to do with repeated measures. And so I was glad to see that you're working on it. So this is really our second week on the repeated measure stuff, complex design stuff. And so I'm hoping that you're getting more familiar with them. Your questions kind of were telling me that there are certainly some questions about the content, but that you're also working through it. So I'm glad to see that. And my plan for today is really to go over the last assignment, so the assignment from last week, the Bolduc and demand, so that if you didn't get full points or if you weren't 100% sure on how to do that, you can see the correct answer and use that as a tool. So I am going to share my screen. So you should be able to see, oops, let's go back, the PowerPoint. And those of you who are on the call, if you can't see the PowerPoint, if you can message me or something. But I assume that you can see the PowerPoint, and what I'll do is I'll just go through like a lecture. So this is essentially kind of an extra recorded lecture. If you're on the call live, just feel free to, I think you can like raise your hand or something, or just turn on your mic and ask if you have a question. The Bolduc and demand article, by now everyone's read it. It is a 2x2 complex design, which means that there's two independent variables. The first independent variable, I'm hoping you can see my cursor on this. The first independent variable, it has 2 levels, and the second independent variable has 2 levels. The 2 independent variables are program, which is alternative and regular. So the first independent variable is program. The levels of that are alternative and regular. The second independent variable was school. The first level was elementary school, and the second level was high school. And so this gives us 4 different conditions. Now, these were independent groups, which means you had different kids in each group. So both program kids were either in the alternative or the regular program, and kids were either in elementary school or in high school. So we had 4 groups: the elementary kids in alternative program, the elementary kids in regular program, high school kids in alternative, and high school in regular. And the main dependent variable for this was self-esteem. So they were interested in how program and school independently and in combination affected self-esteem. So there's really 3 answers or 3 questions that we can answer from a complex design like this. So we can ask, do elementary school kids have different self-esteem than high school kids? So that is looking at the main effect of school, and all we care about is elementary and high school. We're just wanting to compare those two levels of that variable. The second question we can ask is, do kids in the alternative program compared to those in the regular program have different levels of self-esteem? And that's looking at the main effect of program. And then the final one is the question about the interaction effect. So do the effects of regular versus alternative program differ depending on level of self-esteem? Okay, so when we're talking about main effects, we're looking at the effect of one of the independent variables on the dependent variable as if it's the only variable being studied. So if we're looking at the main effect of school, we don't care about what program kids are in. We just want to know the difference between elementary school and high school. We can test the main effects for as many independent variables as there are. For all of the examples I'm going to give you, you're just going to have 2 independent variables, which means you'll have 2 main effects. And then the interaction effect looks at the combination of the independent variables when they're considered simultaneously. And the question that we're asking with the interaction effect is, does the effect of one independent variable differ depending on the levels of a second? Okay. So if we look at the Bolduc and demand article, in the text of the article, it gave you the answers as to what the effects were. For the main effect of school, the question is there a difference? For the main effect of program is the first one. Is there a difference between alternative versus regular programs? what they found was the alternative learning program students had lower self-esteem than the regular program students. The mean for the alternative program was 6.79. For the regular program, it was 7.39, and that was a significant difference. We don't care at all about what age the kids are. This is just looking at the alternative program versus the regular program. The other main effect is for school, and it's looking at, is there a significant difference between elementary and high school students, regardless of which program they're in? And here the mean was 7.41 versus 7.05. That wasn't a significant difference, so there's no difference in self-esteem based on age. So I think a couple of you asked the question of kind of where do these numbers come from? How do I know? And so what you would do is put the numbers in a table like this, okay? Now the initial table will just have the numbers for the 4 groups. If you're not given a table, you need to make one. So some of the recommended stretching exercises, you're given a graph, a bar graph or a line graph instead of the table. The very first thing I would do whenever I'm given one of these problems is put things into a table. I think this is kind of the easiest way to process the information. And so the very first thing you want to do is make a table. Okay, so we've got the means for each group, which was given in the article, I believe. So the kids in elementary school in the alternative program, their self-esteem, the mean was 6.29. The kids in elementary school in the regular program, their self-esteem was 7.92. Those of you who are live on the call, can you see if you can give me like a thumbs up or something to confirm that you can see my cursor? I don't, let's see. Yes, okay, good. Okay, so if I wanna look at the main effect of program, I am comparing the alternative program and the regular program. I'm pretending like I didn't look at kids in different levels of school. I just want to know, are the kids in the alternative program, they have higher or lower self-esteem than the kids in the regular program? So I'm going to say regardless of elementary school, or regardless of school, don't care about school at all. I just want to know whether there's a difference between alternative and regular. So I'm going to average down because I want to know the mean for all kids in the alternative program and all kids in the regular program. So I average down, so I'm going to add these two numbers, divide by 2. So the average kid in the alternative program had a mean of 6.79. The average kid in the regular program had a mean of 7.39. I don't care about school, so I'm averaging across school. So one way to think about this is, okay, if I want to look at the main effect of program, I know my levels of program and I need a number for each level. Okay, so I'm averaging down because I need to know the average for alternative and I need to know the average for the regular program. If I want to know the main effect of school, my goal is to get a number for elementary school and a number for high school. I don't care about program, so I'm averaging across program. So for elementary school, the average is 7.41. For high school, the average is 7.05. So I'm averaging across because if I'm looking at the main effect of school, I need a number for elementary and a number for high school. So that's how you get those main effects. The interaction effects are those numbers in the middle. And if you kind of look at this, you can already kind of come up with a hypothesis as to what's going on, that there might be an interaction, because we see that particularly for program, in high school, there's not a difference between program, but in elementary school, there looks like there is. So this is already giving us kind of a hunch that there may be an interaction effect. But the best way to test an interaction effect is really to graph it. There's a video on Moodle on how to draw a line graph. I'm not too worried about you guys being able to do it on the computer. That's an important skill, but at this point, I just want you to focus on the conceptual stuff. So make sure you watch that video as well if you're unclear. But basically, in a line graph, each one of these dots represents a group. Okay, and when you're trying to tell if there's an interaction effect, the rule is, if you've got a line graph like this, if the lines cross or will cross at any point in the future, so even if they don't actually cross as long as they are not parallel, it's a good indicator that there's an interaction effect. If the lines are parallel, it tells you there is no interaction effect. Okay, so what we can see here is in high school, there's no difference between the alternative and regular program. In elementary school, though, the alternative program is quite low and the regular program is quite high. These lines cross, which tell us that there is an interaction effect. So if I asked you to plot this, these findings and interpret them, I would take a look at it, I would plot it, and I would say, this looks like there is not an interaction effect. Sorry, ignore that. This looks like there is an interaction effect because the lines are crossing. The interpretation part, what you need to do is describe what's happening for each line. Okay, so what I would say is there is an interaction effect in high school. There's no difference between alternative and regular. In elementary school, the alternative program has much lower self-esteem compared to the regular program. And so I've told you what's going on for high school, and I've told you what's going on for elementary school, and that is the interpretation of the interaction effect. Another thing that you're gonna need to do to test an interaction effect, this is another way that you can test this, is using the subtraction method. With the subtraction method, you basically want to know, are the differences from here to here the same as the differences from here to here? So are the differences in elementary school between alternative and regular the same as the differences in high school between alternative and regular? So for the subtraction method, it's a little bit confusing. When you're getting the means for the main effects, it makes a difference whether you go down or across, because that's going to tell you what group you're getting means for. For the subtraction method, we're just trying to figure out whether the differences are the same or different. So you can go either across or down, and it really doesn't make a difference. In this example, we went down. And so we want to know, is the difference between 6.29 and 7.05 the same or different from the difference here? And the rule is that if they are the same or nearly the same, then there is no interaction effect. If these numbers are very different, then there is an interaction effect. So this can be, you know, here, of course I didn't put the actual calculations, which would have been nice, but this is like 0.7. No, this will be negative 0.7. This would be like 0.8, but positive. And the fact that one is negative and one is positive, pretty big difference, tells us that there is an interaction effect here. Okay, so that's the subtraction method. And again, here you just want to know if there's a difference. If they are the same, if the differences between the groups are the same, then that tells you there's no interaction effect. Okay, questions on that? Okay, so go back. I'd encourage you to go back and review your assignment and make sure that you understand it. You might go back and redo it just to make sure that you are clear on that before you go on to the next. This is another example that I thought might be helpful. I'm thinking that just to give you a second example, I will try to go through and do it for you on the whiteboard. I don't have slides prepared for you. But this is a good example of what you might get if you see the results in a bar graph. Okay, so this is a study that was looking at the phenomenon that first-generation college students generally do more poorly than continuing generation students, and trying to figure out why. And so they had two independent variables. The first was generation, so either first generation or continuing generation. The second variable that they manipulated was they had the college president write students a letter that either focused on being independent, which is the message that most college students get. It's important to be the best. You should be able to work independently and think independently, those kinds of things. The thought behind this study was that first generation students struggle in college in part because their parents are constantly giving them interdependent messages saying you should rely on other people, you need to be able to work together, you need to be able to work as a group. And those are the kinds of messages that first generation college students are getting, but then they go to college and they're expected to be independent. And that's part of the reason that they struggle. So the two independent variables were generation, first or continuing, and then the second one was the letter that they got. So they got a letter from the college president, either focusing on an independent message or an interdependent message. Then they had these students try to solve anagrams, so just word problems, and they wanted to see whether there was a difference based on the kind of message that they got. And so what we can see, and I can kind of walk you through this just eyeballing it, when they got an independent message, so when they were encouraged to work independently, what you can see is what we often see, the first generation students in purple do worse than the continuing generation students. When they're encouraged to be independent, those first generation students struggle. But when they got a message from the college president encouraging interdependence, there was no significant difference between the first and continuing generation students. So some of the problems that first generation students struggle with may have to do with the messages they're getting. So if I gave you this example, let me see if I can stop the share and see if I can pull up a whiteboard, and I'm gonna try to see if I can get this drawn for you all. The first thing that I would do, and I've got this on another screen, so bear with me, is I would put it in a table. So I'm going to make my little 2x2 table. And it's not going to be pretty. We're going to use some text here. We've got, let's see, the first variable is, let's do the message. So we got independent over here, and more text here, interdependent over here. And then we have generation, so first gen here, and continuing gen here. All right, so now we've got our table all set up. We need to put in our numbers, so we go back to that line graph, and you can go back in the video if you want to take a look, but we're going back, sorry, to the bar graph. And just taking the mean. So we need the mean for the first generation independent students, and that mean was 6.9. So we can put that in here. We need the mean for the first generation interdependent students, and that mean was 8.8. We need the mean for continuing generation independent, and that mean was 9.2. And then continuing generation interdependent, and that mean was 8.3. Okay, so if I want to look at the main effects, let's say I first want to know, is there a main effect of generation? So do first generation students do better or worse than continuing generation students? I'm going to average across, right? Let's see, can I spotlight here? No, that doesn't do what I wanted it to do. I'm going to average across here. So I want to know the mean. If I want to know the main effect of generation, I want to know what's the average for first generation students. So I'm going to add 6.9 plus 8.8 and divide by 2, and that gives me 7.85. Okay. And then I want to know the mean for the continuing generation students. So I'm going to do 9.2 plus 8.3 divide by 2 is 8.75. Oops. 8.75. Okay, so just looking at this, it looks like My continuing, so if I wanted to assess, is there a main effective generation? Looking at these means, I would say it looks like, yes, there is a main effective generation, and those continuing generation students are doing better on the task compared to the first generation students. Then I want to look at my second main effect, which is the main effect of the letter, the message that they got. So I'm going to average down. And so first I want to know for what's the average for the students who got an independent letter. So I'm going to do 6.9 plus 9.2 divided by 2 is 8.05. And then we're going to look at the mean for the interdependent students. And so that's 8.8 plus 8.3 divided by 2. And that's 8.55. Now, there are other tests that we can do to see whether there's a statistically significant difference, but these don't look like they're hugely different, right? So there's probably not a main effect of the letter on its own. Okay, so that's what you need for the main effects. If I were looking at this, if I were asked a question, if I gave you a question, the question would be something like, test the main effect of generation. Average across and say, it looks like continuing generation students perform better on the task than first generation students. Then I would say, okay, test the main effect of the letter. And taking a look at this, I would say it looks like I would average down, and I'd say there doesn't look to be a main effect of letter, and students getting the independent and interdependent letters get approximately the same score. Okay, so the next thing you want to test is the interaction effect. Okay, and we know looking at the bar graph that there probably was an interaction effect. I can show you how to do a line graph. I'll walk you through the whole thing, I guess. But let's do, since we have our table up here, let's do the subtraction method first. So what I'm going to do is I'm just going to erase our means, because when we're, when we're looking at the subtraction method, we're not looking at means anymore. We're just comparing. If I want to look at my means, again, it doesn't matter whether I average across or down when we're using the subtraction method to test for an interaction, but let's go across just to do it. So I want to look at the difference between 6.9 and 8.8. So I'm going to do 6.9 minus 8.8, and that gives me a difference of negative 1.9. And then I'm going to look here, and so we're going to do 9.2 minus 8.3. Whoops, 9.2 minus 8.3, and that gives me a difference of positive 0.9. Okay, the fact that these are almost 3-point different tells me that yes, there is an interaction effect. Okay, so the next thing we're going to do is plot it. Right, so we are going to, I'm going to go ahead and just clear this. Let's clear all drawings and let's draw a graph. Okay. And we want to insert another line here. Apologize, technical difficulties as I get my graph drawn here. Okay. All right. So our dependent variable here is the number of anagrams solved. Okay. All right, let's put the generation down at the bottom. Okay, so our first independent variable is generation. We'll have first, and continuing. And our second independent variable is going to be indicated by the different lines, right? So one line will indicate independent letter, and the second line will indicate interdependent. And then let's just stick a couple numbers in here. So it looks like it ranges from 6 to 10. So you need to figure out the appropriate scale. Look at the range of your numbers. We're going to do, let's just do this 6, 8, and 10, just to make things simple because it's a little difficult. Okay. So we want to draw, and each dot here represents one of our groups. So the first thing I'm going to do is, let's say we want to draw the line for the independent message first. So I need a dot for the score for first generation independent, and their mean was 6.9. So we're going to put a little dot right here. Well, let me, okay. And then I need a dot for continuing generation independent, and their mean was 9.2. Oof, the scale on this is really not good. Okay, and then I'm going to connect them with a solid line. Okay, and I'm also going to put my line here so I know that that indicates continuing or independent. Okay, next I'm going to draw my line for interdependent. I'm going to make them in red. I'm going to start with a circle. So I need a dot for first generation interdependent, and their mean was 8.8. And I need a dot for continuing generation interdependent, and their mean was 8.3, which is right here. I'm going to connect them with a line. Okay, and this indicates interdependent. And so even with this rough kind of ugly graph, what we can see is that these lines do intersect. And so I would say, yes, just like in our subtraction method, it looks like there is in fact an interaction effect. And then I would explain what's going on. For the students who got the independent message, which is the black line, first generation students did much worse on the anagrams compared to continuing generation students. In contrast, the students who got the interdependent message, there was not much difference between first and continuing generation students. Okay, so that's essentially how you solve that problem. Those are all the components that you're going to need to be able to explain. Okay, so I'm going to go back and share my screen because I had a couple more. So that was this first one. There's another slide on this. So what I encourage you to do is pause this video and do the exact same thing. So this is the same study, but instead of having the number of correct responses as the dependent variable, for this figure, the dependent variable is how difficult students thought the task was. So you've got the same two independent variables, generation and the message they're getting, but different outcome, a different dependent variable. So I'd encourage you to, as you're watching this video, pause this and go back through and do exactly what I did for the number of correct anagrams for this, this graph, or this data as well. Okay, all right. The last thing that I wanted to comment on was what we're going to do for the final paper. So I sent you all an email about this. I didn't get very many responses, so if people are watching this and can weigh in, either if you're live and want to give me feedback, or if you're watching this and want to email me later. Basically, I see two choices for a final paper. Either way, we're going to deal with it in the last 2 weeks of class, so you don't really need to be thinking about it right this second. I thought it might be easier to just pick one dependent variable, so one topic, and have the entire class write their paper on that topic. I might pick like intelligence or something like that. It's the same setup, it's using your actual data, but rather than have to analyze, 6 sets of data, this way I can walk you through step by step. I know all of our outcomes will be the same, so I'll be able to give you very specific feedback on your results and your discussion and some suggestions on how to interpret it. So that's option A. That is one choice. But what that means, I'm not going to make you rewrite your introduction if you weren't, for example, in the intelligence group. You'll keep your introduction as is, but you're going to have to kind of shift your focus for the last section of the paper. So it's not going to flow as well, and that's kind of the downside, and you're not going to get the outcome for your specific topic if you were curious about it. The other option is that I can do what I had planned and analyze results for each group specifically. I would basically make a video or maybe even set up a live chat where I analyze I analyze the results for your specific group. This way your paper would flow, you'd have your group's discussion, or you'd have your group's results, and so you'd know, and you'd have your results for a specific topic. Kind of the downside of that, though, is I'll give you kind of a general template of what you need to put in your results and discussion section. So you'll have that general formatting, but because everyone is going to have different results, it won't be as specific or tailored to our results. So you will have a separate video of me analyzing your results to refer to, but the guidelines of what's going to go into those sections of the paper will be more general, and you'll just have to apply your results. I have no problem doing either one. I just want to know what will make this a little easier for you guys. So if you want to email me and let me know which option you prefer. I've only gotten a couple responses, and honestly, both options are tied. So it seems like some people really prefer option A, some people prefer option B. If I can get some more feedback on that, that will help me make a decision. Either way, I'll show you how to analyze the data. I will be doing the analysis for you. You're just going to need to write it up. And so you'll have that guidance. Okay. All right, so that is all I've got for today, unless those of you who are on here live have any other questions. But I'm hoping that helps you really kind of cement what's going on and what you need to do for your complex designs. You've got another assignment due this week, and then also the test on this chapter due this week. Okay, I'm going to go ahead and stop the recording. And if those of you who are live have more questions, you're welcome to ask me after.